All right, I think number 45 is a really cool problem, which usually is bad news for you guys when a math teacher says that. You've been given three functions here, and I think you'll notice they all kind of look trigonometric, but I don't want to get into that assumption here. And we're going to try to label these three functions in such a way that one of them is the derivative of the other, and the third one is the derivative of the second one. And once I figure that out, then I'll worry about these F's and G's and H's, and we'll label all that stuff. So let's just take this in order. I want to start off by looking at the graph of A. And I'm wondering right now if B is the derivative of the graph of A. So the first thing I would do is look for turning points, a max or a min, where we would have a horizontal tangent. And that happens twice right here on the graph of A. Boy, I really wish they had given you guys some values right here. I don't want to use A and B and C, but how about I call this, I don't know, I'll call that value there E, and this value right over here, I'll call that F. Those same two values show up a lot in these three graphs, so I wish they'd given you all three of these here, but that's it right here. There's E, and then this would be F. Okay, so if I'm right about that, let's see what's going on. In the graph of A right here, it's got horizontal tangents at E right here and F right here. That would mean that the derivative of this graph would have to equal 0 at E and F. That does not happen here in graph B. Right here at E, the value of this derivative is negative. I don't know how negative it is, but it's clearly not 0. And at F, where the value of the derivative of A would be 0, here this one is positive as well. So all I know for sure right now is that B is not the derivative of A. But what if I jumped over here and took a look at C? What's going on here, guys? At E, the value of the derivative of A should be 0, and sure enough, that happens right here, and the same thing should happen at F. Okay, that's encouraging then. The other thing I would worry about is the behavior. I know that the graph of A is increasing here before we get to E, which means its derivative should be positive. And sure enough, the graph of C is positive. It exists above the x-axis for values of x in between 0 and E. Then, in this middle area here between E and F, the function in A decreases. So its derivative would have to be negative, and that's what happens here in C. And then after F, this function in A increases. Its derivative would have to be positive. Okay, so I think we found something here, guys. I think C could be the derivative of A. So in fact, let me write that. C, I think, is the derivative of A. I'll just call that A prime. The question now is, where does B figure into this whole mess? Either B is kind of the top function in this food chain right here, and that A could maybe be the derivative of B, or it could be possible then, guys, that B is kind of below everything, and B is the derivative of C. So I think I'm going to erase, I shouldn't have erased the E and the F. Let me get rid of everything I had in blue right here and right here. Oh, and that's going to be messy, but okay, gotcha. That's where we're at. So my question here is, where does B fit in? Could B be the derivative of C? Well, if I take a look at C, the only real horizontal tangent line I think I see is right there, kind of right in between that E value that was right here and this F value right here. So maybe if I call that G, how about that? It looks then like that would be a horizontal tangent line right there. So the derivative of C would have to be 0 at G. Well, that happens right here in the middle. That's kind of interesting then. What else do I notice? Prior to that, the graph of C decreases until we get to this G value. Its derivative would have to be negative. That happens here. The graph of B is negative until we get to that G value right there in the middle. And then after that, the C function simply increases. Its derivative would have to be positive, which it is right there. So I think what we found here, guys, is that B is the derivative of C. B is the derivative of C, or I'd call that C prime. So this is important here. I think we've kind of established the hierarchy here between these three functions. Now I'm going to go ahead and play their little game right here, guys. We've got to come up with the names of these functions here. F prime of x has to equal g, g prime of x has to equal h of x. So what I would probably say here, boy, the g is the one that gets used twice. I think that's going to be the C here because that one got used twice as well. I think what I'm saying then is that A would be f of x right here. Okay, if this were the graph, then f prime of x, the derivative of this function, would equal g of x. And we just said that the derivative of a is c, so I think this one here is going to be g of x. And then, let's take a look then, the derivative of g would be the function we would call h. Well, we said that the derivative of c would be b, so this one here in the middle would be h of x. So kind of an interesting way of looking at it here, guys, but okay, that's the way I think this one has to shake out. The A graph is f of x, B is h of x, and C then would be g of x. See, I told you that problem was going to be fun. You're welcome, everybody.